The sides of quadrilateral ABCD all have a length of 5 units. All have a length of 5 units, and all of its internal angles have the same measure. One of the 4 vertices of the quadrilateral is at 5, 0. All of the following points could be another vertex of the quadrilateral ABCD except. Okay, so let's break this down first. We know that the sides of the quadrilaterals all have a length of 5 units, and they all have the same angle measures. So that means that we are looking at a square. A square is the only quadrilateral that satisfies both of these criteria. And then all we have to do is figure out which of these vertices it's going to be. So we're going to have to draw this, and in order to give you a good visual for what this looks like, I'm going to cheat a little bit and put a Cartesian plane on the screen here so you have a good idea of what this looks like. On the actual ACT, you will not be able to do this, but I am doing this so that you can visualize what's happening, and you should be able to replicate this because it's very difficult for me to draw on this interface right over here. Okay, so here we go. Here's our Cartesian plane. It tells us that one of the 4 vertices of the quadrilateral is at 5, 0. So that's going to be 1, 2, 3, 4, 5, 0. So here's one of the vertices. That's going to be at 5, 0. And then it says all of the following could be another vertex of the quadrilateral except. So if this is a square, we know it has length of a length of segments of length 5. So we know that we can go up 5. So I'll go ahead and label this point right over here. This is going to be 5, 0. That's my point right here. So it could be that the square is drawn on the top left. This is the bottom right vertex. So that goes 1, 2, 3, 4, 5. This is a possible vertex right over here. And the square could be there. And then 1, 2, 3, 4, 5 right over here. So let's go ahead and label these points. So it could be 5, 5. And then this is going to be 0, 5. And that would mean that the remaining vertex for this square is going to be right here. And that's going to be 0, 0. And we can continue. So it could be this particular square right over here, the one that we just drew. It could be a vertex on that square, or it could be a vertex on a square right over here. And that would require us to go 1, 2, 3, 4, 5 units this way. And so that gives us 10, 0. That means we would have to go up 1, 2, 3, 4, 5. So this would become 10, 5. That's one possibility, and that would mean that we're looking at this as the other edge of this square. It could also be this one right over here. It could also be the top right vertex. So it could be 1, 2, 3, 4, 5. I'm going to speed this up a little bit, and this gives us 0, -5. And we come back across this way. It could be this one. Let's go ahead and make sure we draw it properly. This is going to be 5, -5. And the last one would be the square on the bottom right. And this is going to be 10, -5. Right over there. So it could be any one of these 4 squares that this initial points, I'm going to go ahead and circle this one, that this point could be a vertex on any of these 4 squares. And then it says all of the following points could be another vertex of the quadrilateral except. So if it's this quadrilateral, these 3 would be the vertices. If it was this quadrilateral, it would be these 3 vertices in addition to the one that we have. If it was this one, it'd be these 3. And if it was this one, it'd be these 3. Let's see which ones actually do exist. Could 5, 5 be one of the vertices of that square? Yes, it could. 5, 5 checks out. So that could be a vertex. Does 5, -5 check out? 5, -5. Yep, that also could be a vertex of our quadrilateral. That's also possible. Could it be 0, 5? So 0, 5. Yes, that one also checks out. Can it be -5, 5? So -5, 5 is right here. -5, 5. This right here is letter D. This right here is letter D. -5, 5. And this one actually does not check out. And let's check the other one, 0, -5. This one checks out as well. That one is correct. So the only one that cannot be a vertex is going to be letter choice D. So all the other ones will get eliminated, and our correct answer is going to be D, because -5, 5 is the only point that's listed here that cannot be another vertex of the quadrilateral that this point right here belongs to. So our correct answer is D for donut.